Hello students, let me explain the experiment estimation of barium chloride by conductometric titration. Let me see what are the apparatus involved in this experiment. This is digital conductivity meter and this is conductivity cell and 250 ml beaker to take the analyte and a burette to take the titrant and a pipette to pipette out the analyte sample into the beaker. And a magnetic pellet to stir the solution thoroughly for the smooth mixing. This is the wash bottle to take the distilled water, and we have to rinse the conductivity cell thoroughly before starting the experiment. So first rinse the conductivity cell thoroughly by splashing water and splash water inside this bowl to clean the platinum foil inside this conductivity cell. Since it is barium chloride estimation, there is a chance of deposition of barium sulfate on the platinum foil, so we have to give a thorough wash before starting the experiment. Splash more water inside and wash it thoroughly. After rinsing, take the filter paper and wipe the conductivity cell to drain the water inside the conductivity cell. These are the solutions provided for this experiment. This is burette solution, that is titrant to fill the burette. And this is the analyte barium chloride solution to pipette out 40 ml into this beaker. After pipetting out 40 ml of the given barium chloride into the beaker, place the beaker on the conductivity meter. Take the magnetic pellet and rinse it with distilled water. Wash it thoroughly with distilled water. And then transfer it into the beaker gently. Now fill the burette with burette solution. First rinse the burette with tap water and then distilled water. And rinse the burette with little bit of burette solution, sodium sulfate also. Take small amount to rinse, don't waste the solution. And rinse the funnel with distilled water. And place the funnel at the top of the burette and tilt the funnel a little bit to transfer the solution, sodium sulfate, into the burette. Always take some excess solution above the zero level. After that, you remove the funnel. After removing the funnel, you can adjust the level 0 and also you have to fill the burette without any air gap at the tip. So take excess solution and open the wall stopcock freely so that you can fill the tip of the burette also without any air gap. Switch on the stirrer. This is 40 ml of pure barium chloride solution. Stir the solution for 1 minute. After 1 minute stirring, switch off the stirrer. Let the pellet come to the rest position. Then immerse the conductivity cell into the beaker solution. Ensure that the conductivity cell is touching the base of the beaker, and also you should not place the conductivity cell on the pellet. You carefully immerse the conductivity cell. It should touch the base of the beaker, and you can read the initial conductance of pure barium chloride, and you have to note the readings. This is actually without adding sodium sulfate. So the volume of sodium sulfate is 0.0. The conductance that now we got is 5.5 millimole. After taking the initial reading, lift the electrode just above the solution level. And you have to now add the burette solution into the barium chloride, that is sodium sulfate into barium chloride. You have to take the burette from the stand and add 1 ml. Okay, 1 ml of sodium sulfate. Before that, you ensure that the burette solution is filled up to 0.0 level. The lower meniscus should touch the 0, and also ensure that the tip is filled completely without any air gap. So now you have to add 1 ml into the pipette solution. Now the sodium sulfate is added into barium chloride. So now we got the precipitate of barium sulfate into the solution. Stir the solution for 1 minute. Thoroughly you have to stir the solution for 1 minute. After stirring 1 minute of time, switch off the stirrer and let the pellet come to the rest position and immerse the conductivity cell. Ensure that your conductivity cell is touching the base of the beaker. Now you take the reading after adding sodium sulfate into barium chloride. See, now there is a decrease in the conductance. So this is for 1 ml addition of sodium sulfate. That is, now the volume of sodium sulfate is 1.0. For that, what is the conductance is 5.38. So some decrease in the conductance we observed. For every 1 ml addition of sodium sulfate, there is a decrease in the conductance value till it reaches the equivalence point. After the equivalence point, there is increase in the conductance we observed. So continue the titration for every 1 ml addition till and after the equivalence point you take 6 more readings. After taking 6 more readings, now the experimental part is over. Now the conductance value, you see, there is a decrease in conductance till it reaches the lowest value of 4.9. After that, for the further addition of sodium sulfate, there is an increase in the conductance. So this decrease in the conductance is due to the replacement of fast moving high conductive barium ions by sodium ions. And after that, there is an increase. That is because the addition of excess sodium ions and sulfate ions. The lowest conductance was observed at the equivalence point, where all the barium 2 plus ions are completely precipitated. After completing the experimental part, plot the graph to get the end point. The end point of this titration can be obtained graphically by plotting the conductance value in y-axis and the volume of sodium sulfate in x-axis. Drawing the straight line by connecting the points, we will get two different straight lines which will intersect at a point. From the intersecting point, if you are plotting a straight line to the x-axis, this will give the volume of sodium sulfate which is reacted with barium chloride. The volume of sodium sulfate you can get from the graph. The strength of standard sodium sulfate is given, and volume of barium chloride that we have pipetted out 40 ml. So by applying law of volumetric analysis, V1 N1 is equal to V2 N2, we can find out the strength of barium chloride by substituting the values, that is volume of sodium sulfate and the strength of sodium sulfate divided by volume of barium chloride. We can get the strength of barium chloride. The amount of barium chloride present in liter can be calculated by multiplying the strength into equivalent weight of barium chloride. The equivalent weight of barium chloride is 122.14. So by substituting the strength and multiplying that by equivalent weight, we can get the amount of barium chloride per liter in grams.